Okay, so we are going to start by finding the zeros of the polynomial function. This can help us factor the polynomial, graph the function, and solve the related polynomial equation. So here it says the polynomial is y equals x plus 2 times x minus 1 times x minus 3. When it's in this form, it's actually pretty easy for us to find the zeros. It's the same as when we were factoring and solving for the zeros in quadratics. We take each of these terms and we set them equal to 0. So I'm going to start by setting x plus 2 equals 0, x minus 1 equals 0, and x minus 3 equals 0. Okay, so x plus 2 is equal to 0. I solve that by subtracting 2 from both sides. I end up with x is equal to negative 2. For the second one, x minus 1 equals 0, so I'm going to do the opposite of minus 1. I add 1 to both sides, and I get x is equal to 1. So these are just one-step equations here. So for the third one, adding 3 to both sides, I end up with x is equal to 3. So this tells us 3 points on our graph: negative 2, 0, 1, 0, and 3, 0. Okay, so we actually need to find more points on our graph in order to figure out what the function looks like. So we're going to choose points that are between our 3 zeros. So I need a point between negative 2 and 1. I need a point between 1 and 3. And that can be any number. And so for negative 2 and 1, I'm going to choose 0 because that's usually easy to plug in. So I take my number that I'm choosing 0. I need to figure out what is the y value when x is 0. So I plug that into my function. My function is y equals x plus 2, so I'm plugging in 0 plus 2, x minus 1, so 0 minus 1, and x minus 3, so I'm plugging in 0 minus 3. And then I just simplify. So 0 plus 2 is 2, 0 minus 1 is negative 1, 0 minus 3 is negative 3, and then I'm just multiplying these 3. So I end up with a y value equal to positive 6. So that gives me another point. That gives me an additional point between my 2 zeros. And then I'm going to choose another point between 1 and 3. So obviously I'm going to choose 2. So I need to plug 2 in and see what my y value is going to be. So if I plug 2 into my function, again the function is y equals x plus 2, x minus 1, x minus 3. So when I plug 2 in here, I have 2 plus 2, 2 minus 1, and 2 minus 3. So I'm going to simplify this. So 2 plus 2 gives me 4, 2 minus 1 is 1, 2 minus 3 is negative 1. And then just like before, multiplying these, I end up with a y value of negative 4. So that gives me 2 additional points, 2 points that are going to be between my 3 zeros. So now that I have the 3 zeros and I have my additional points, I have some idea what my graph will look like. So I am ready to graph them. Okay, so now we are going to graph these points. So we start by plotting the zeros. So I'm going to start by plotting my first point at negative 2, 0. So I go to the point, negative 2, 0, and plot it. Okay, my other 0 is at 1, 0, so I go over to 1, go over to 1, 0, plot my point. And then my last one is at 3, 0, so going over to 3, 0, plotting my point. So this is where our function is going to go through the x-axis. The additional points then, I'm going to go ahead and plot those in blue. My first additional point's at 0, 6, so I go to 0, 6, plot my point. And then my next additional point was at 2, negative 4. So I'm going to go over to 2, down to negative 4, plot my second point. And so now I have a general idea of what my graph is going to look like. So I'm going to go ahead and draw my line in. I know that the in behavior for this one, since my equation had positive coefficients, I would have a down and up in behavior, meaning that the left side is going down, my right side is going to be going up, and then I'm just going to draw my function through these lines, or these points. Now, these points don't necessarily mean this is where the turning point is. The turning point is going to probably be somewhere around here, but this just tells me where my line is at this point only. It doesn't tell me that's where it turns, so this isn't where I'm going to like make my hump here. Okay, I'm going to go maybe up a little, go down, and up. Okay, so I go through those additional points, making sure that I go through my zeros as well. And those additional points don't necessarily mean that that's where the turning point is. So this is going to give me a general idea of what my graph looks like. And please make sure you try the U-try problem. The U-try problem at the bottom is done the same exact way, finding the zeros for these three, and then using those 3 zeros to figure out points in between them, and then graphing. Okay, so next we're going to look at how to find the zeros of the graph if we're not actually given, if we're given the polynomial in standard form instead. So I have polynomial here, x to the third minus 2x squared minus 15x. So first I'm going to look for a common factor, and there is a common factor between these three. It is x. I can take an x out of each of these terms. So I'm going to start by taking out my greatest common factor, and then what goes inside the parentheses is what's left over once I take an x out. So for the first term, I get x squared minus 2x minus 15. All I've done so far is just factored out an x. The next part is going to be similar to what we did in the last chapter. In chapter 3, or unit 3, we are now going to factor the x squared minus 2x minus 15. So x squared minus 2x minus 15, I'm looking for the two numbers that multiply to give me negative 15 and add to give me negative 2. And if you can't just think of them off the top of your head, list the factors of negative 15. And so for me, I already know that this is going to be negative 5 and positive 3. So my two factors are x minus 5 and x plus 3. To find the zeros then, I go through the same exact procedure I just went through in the last problem. I set each of these equal to 0. So x equals 0, x minus 5 is equal to 0, and x plus 3 is equal to 0. So this one is actually very easy since it's just an x is equal to 0, I don't have to solve that one. For the next one, if x minus 5 is equal to 0, then I just add the 5 on both sides, I get x is equal to 5. And then for the third one, if x plus 3 is equal to 0, to solve, I subtract 3 from both sides, I get negative 3. So I have my 3 zeros. And then graphing it, I would go about that doing the same thing that I did on the last example. Okay, so my zeros are negative 3, 0, and 5. So that means I need a point between negative 3 and 0 and a point between 0 and 5. So I am going to find those additional points by choosing x values that are between these numbers and plugging them into my function. So I'm just going to go ahead and choose two random numbers. I'm going to choose, let's say, negative 1 in between negative 3 and 0. And between 0 and 5, I'm going to say positive 1. So all I need to do is take that number and plug it in. So I'm going to take negative 1, plug it into my function. So negative 1 to the third power minus 2 times negative 1 to the third power minus 15 times negative 1. And when I plug that in, I end up with 16. Okay, and then I'm going to do the same thing plugging in positive 1. And I'm going to write the work for that one down here. Okay, so plugging in positive 1. So I'm plugging this into this function. So it's going to be positive 1 to the third power minus 2 times positive 1 squared minus 15 times positive 1. Okay, and that I'm just putting in my calculator and calculating it. That gives me negative 16. Okay, so I now have 2 additional points. I'm going to go ahead and graph these. Okay, so I'm going to start by graphing my zeros. So -3, 0, 0, 0, and 5, 0. And then graphing my additional points in red, -1, 16. And then 1, -16. And then I'm just going to draw my line in. So again, this is going to have a down, up in behavior. And I'm just going to go through my points. And again, the additional points doesn't necessarily need to be the turning point. We can actually go a little bit below or a little bit above our additional points, because the line probably does not turn at that exact point. We're just kind of estimating here. This is just a sketch. So this is a general idea of what this graph will look like. And make sure you attempt the U-try problem. So doing this the same way, but keep in mind for this one, we have a negative coefficient. For the previous problem, the example we just did, it is a positive coefficient, meaning that we had the down, up. But this time we have a negative coefficient, so when we graph this one, it's going to go up, down. It'll be going up toward the left and down toward the right. So keep that in mind when you plot your zeros and you're plotting these points. Okay, and finally, what is a cubic polynomial function in standard form with these zeros? So if I'm giving these zeros, I'm just working backwards. If I know x is equal to -2, x is equal to 2, and x is equal to 3, I'm going to basically put these back into the binomial form here, moving the -2 to the opposite side, okay, by adding it. So we end up with that x plus 2 equals 0. These are binomials. We need them to be back in that form. So bringing the 2 over, subtracting the 2 from both sides, x minus 2 equals 0. And then for the third one, same thing, x minus 3 equals 0. So these 3 binomials are going to need to be multiplied. We're going to need to FOIL here. So I'm going to start by multiplying the first 2, x plus 2 times x minus 2. So right now I'm only working with the first 2 binomials here. So I'm going to FOIL these, and if you guys remember or don't remember, FOIL is first, outer, inner, last. So that means I'm starting with the first term in the first binomial, the first term in the second binomial. So I am doing x times x. So x times x gives me x squared. Then I'm going to be doing the outer terms. So that means I am working on the term all the way to the right, and the term all the way to the left. Sorry, right, left. So x times -2. I'm going to make that minus 2x. And then I do the inner terms, so the 2 terms that are on the inside here, 2 and x. So 2 times x is positive 2x. And then finally the last term, so the last term in the first binomial, the last term in the second binomial. So 2 times -2 is going to be -4. Okay, and the x minus 3, what I'm going to do with that is just kind of bring it down for right now. So all I've done, like I said, all I've done is FOILed these first 2 binomials. Now I need to simplify. So x squared times x squared minus 2x plus 2x minus 4. I have to simplify this by combining like terms. When I combine a -2x with a positive 2x, these end up canceling out. So I have x squared minus 4 and x minus 3. So now again, I can go ahead and FOIL. I have 2 binomials, so FOILing means that I am going to do x squared times x, my first terms. And I'm going to do this in a different color. X squared times x is going to give us x to the third. X squared times -3 will be -3x squared. My inner terms, -4 times x is going to be minus 4x. And then finally my last terms, -4 times -3. Negative times a negative will make that a positive 12. And then from here, again, I would combine like terms. In this case, I do not have any terms that I can combine because I have an x to the third, negative minus 3x squared, minus 4x plus 12. The only time that we can combine terms is if they have the same exact variable with the same exact exponent. So all of these have different exponents, which means that I can't combine them. So my final answer then is going to be y is equal to x to the third minus 3x squared minus 4x plus 12. Okay. Again, don't forget to go back into the U-try problems. If you do not do the U-try problems, you do not get credit, any credit for your notes. Please make sure you do them.